Hello everyone. This video is titled Section 2.6 Solving Compound Inequalities. And in this video I'm going to be taking you through the Knewton Alta assignment for Section 2.6. Now please know that the questions that I see in this video won't necessarily be the exact same questions you see when you work on the Knewton Alta assignment for Section 2.6. But the objectives will be the same, and how I work on the problems will be the same as how you should be working on the problems yourself. Alright, so you may not see the exact same questions, but you will see how to do questions related to a certain objective. Alright, so here it is. Now again, you're not going to see the word preview, or you're just going to see the section 2.6 solving compound inequalities. You see the mastery bar, and again, don't forget the more instruction button if you ever need it to help you out with certain questions. Alright. Now this section has two objectives. The first one is titled, is called Solve a Compound Inequality Involving Unions. These compound inequalities involving unions are inequalities. They're two inequalities connected by the word or. So you see I have solve negative 5x minus 3 is greater than or equal to 2, or 4x minus 2 is greater than or equal to 5. And write the solution in interval notation. Alright, so I'm going to pull this up on a piece of paper and work on that. Alright, so I've written out that inequality. Now, when the word or is the connector of two inequalities in a compound inequality, it's very easy to find solutions. When you have the word or involved, any number that satisfies either inequality belongs to the solution set. Right, any number. Alright, this marker's going faint, sorry. So any number that satisfies, makes true either inequality belongs to the solution set. Right, so it's very loose, very inclusive. So any number that satisfies this first inequality belongs to the solution set. Any number that satisfies this second inequality also belongs to the solution set, right? So very simply, we just solve each of these. So for the first one, again, I want to get the variable alone on one side. Usually I like it on the left. So first I'd be adding 3 to both sides. That gives me negative 5x on the left is greater than or equal to 5 on the right. Then I would divide both sides by negative 5. And when you divide both sides by a negative number, right, whenever you multiply or divide both sides of an inequality by a negative number, the inequality symbol changes direction, it flips. So this is greater than or equal to becomes is less than or equal to. And then on the right side, 5 divided by negative 5 would be negative 1. Right? And then again, I got the word or connecting these, so or. And then same thing, I solve this second inequality as well. So I would add 2 to both sides, and that gives me 4x on the left is greater than or equal to 7 on the right. Then I would divide both sides by positive 4. Now that's a positive number I'm dividing by, so that the symbol doesn't change. So you have x is greater than or equal to still. And then 7/4 would stay 7/4, right? That fraction doesn't simplify any further. And here's a description of all the solutions of this compound inequality. All the numbers less than -1 or -1 itself, right, less than or equal to -1, these satisfy the first inequality. And since they satisfy either one, they belong to the solution set. I'll graph those. Or, then all the numbers greater than or equal to 7/4, those numbers satisfy the second inequality. And since they satisfy either one, they also belong to the solution set. Right, so I can graph the solutions below. Right, -1 was mentioned, positive 7/4, which would be to the right of -1, that's also mentioned. And all the numbers less than or equal to -1, so to the left of -1 or -1 itself, these all satisfy the first inequality, therefore satisfy the compound inequality. And then x is greater than or equal to 7/4. All the numbers to the right of 7/4, including 7/4, right, greater than or equal to. So again, you could put the closed points there or the rectangular brackets, same thing. But all these numbers satisfy the second inequality, therefore these numbers satisfy the whole compound inequality, right? Or again, or is very loose, very inclusive. So here's a graph. Now I'm going to write the interval, right? Take this picture of solutions we just drew and describe the same set of numbers in what's called interval notation. Interval notation. Now, you always go left to right. You always go left to right, low to high. Now notice here that there are two pieces of this graph. Right, there's this picture of the solutions, this piece to the left of -1. Then there's a break in the graph, a gap, where there are no solutions, and then the solutions pick up again from 7/4 onward. When there are multiple pieces of solutions like this, you need to write an interval for each piece. So going left to right, this first piece, you got from -infinity, right, because there is no left end, up to -1. Now on -infinity, there's always parentheses, right, because -infinity is not a number. And we stated -1 is a solution of this compound inequality, right, because it satisfies at least one of them. It satisfies the first one. So I put a bracket. Remember, rectangular brackets go on numbers that are solutions. All right. Then to represent, kind of to represent the gap, also to represent the word or, is this union symbol. All right, this is called the union symbol in set notation. Right? And it really just means the word or in set notation. So the solutions of this inequality are, the numbers less than or equal to -1, or these numbers greater than or equal to 7/4. So now I'm on the separate piece, right? So I like to tell people to help them out is, that this union symbol basically kind of represents this gap, any gap in the picture. And then the second piece, going left to right, low to high, starts at 7/4, comma, goes up to positive infinity. 7/4 we said was a solution of the compound inequality, right, because it satisfies the second one. So a rectangular bracket on the 7/4 and always, always, always parentheses on the infinities. And this is what we are asked to enter, right? This here, interval notation. So this is what I'm going to enter in on the website, right? So here, click on this, that open space there. So going left to right, we're going from -infinity. So negative, and the infinity symbol should be around. I'm not seeing the infinity symbol, but I can find it. So you go to maybe basic. Yeah, there it is. See, drop down the menu for the keys, and there I'm seeing infinity. All right, -infinity, comma, and click back up here, comma, and then we had a -1 at the right end of that first piece, and then a bracket. Oops. And then make sure you've got a bracket on the right end of that. Then the union symbol. So that's where you're going to have to go back down to the set notation, sets. And you see this is the union symbol. And later we'll see the intersection symbol. There's also something called the empty set. This circle with a slash through it. If there's no solution, you enter the empty set here. But I'm entering the union symbol, which apparently we can do with Shift, Alt, and then UN. So let me test that out. Go Shift, Alt, UN. Yeah, whatever, just go here. It looks like the typing's not working. Alright, and then I need infinity again, so I'm going to go back to basic, the basic menu, and our second interval had a bracket, 7/4, comma, infinity, and then parentheses. And there's the interval notation for our solution set to this compound inequality. And it says perfect, wonderful, great. Right. And again, read please the answer explanations. If you get something correct or incorrect, especially if it's incorrect, read through the answer explanations and make sure you know what's going on, and try to figure out what went wrong, so that way when you come up against another question in that objective, hopefully it'll be easier. All right. Next question. So it's on the same objective. Solve a compound inequality involving unions, involving the word, connected by the word or. And again, I'm going to write this out and do the same thing I did in the last example. So again, I'm just solving each one. First, I'd add, this first inequality, I would add 6 to both sides, giving me -x on the left is less than or equal to +3. And then I would divide by -1, and that would flip the symbol. Right? So that becomes is greater than or equal to, and you'd have x on the left, -3 on the right. Right? So x. So these are solutions. These belong to my graph because they satisfy the first inequality. Remember, when the word or is the connecting word, any number that satisfies any of the inequalities, either one, belongs to the solution set. Right, so again, we got the word or connecting here. Then this inequality, I'd be subtracting 3 from both sides first, and then we have -4x is greater than -4. Then I would divide both sides by -4, and since I'm dividing by a negative, that'll flip the symbol. This is greater than will become is less than. And we have x is less than and +1, right? Negative divided by negative is positive. So here we go. All right, here's a description of our solutions. If I made a graph, the numbers -3 and +1 are mentioned. Right. And all the numbers greater than or equal to -3, so that's all these numbers here. These would be solutions greater than or equal to -3, right? So you can put a bracket there, or a close point. So all these numbers belong to the graph. So do all the numbers less than 1. Well, so 1's not included, but wait a minute, 1 was included from the first graph, and all the numbers less than 1 are these numbers to the left of 1. And look at what happens. If I do, if all the numbers greater than or equal to -3 are solutions of the compound inequality, also, all the numbers less than 1 are solutions because they satisfy the second one. And you look at both graphs together, do their union, that's everything. Every real number. Right? All real numbers are solutions. 1 is a solution, even though I put a hole there, because it satisfies the first one, right? 1 belonged to the first picture. So technically that's filled in by the first picture. Right? So everything, every number you can think of satisfies at least one of these. Right? All real numbers are solutions. Fantastic. Now the interval for all real numbers, right? Interval notation. Again, you're going left to right. Now there's no gap, right? It's everything. There's no gap, there's no break, there's no hole in the graph. So it's one big piece. From left to right, you're going from, there's no left end, so I indicate that with negative infinity, comma, and then going left to right, there's no right end, so I indicate that with positive infinity. And, negative infinity, positive infinity, they both have parentheses on those, but that's the interval notation for all real numbers, saying that every number you think of is a solution to this compound inequality. Any number you think of satisfies at least one of these inequalities. Right? And that's what I'll enter. Right? So here again, I want to go back to the basic menu so I can see the infinity symbol. And then in parentheses, negative infinity, comma, positive infinity. And then close parentheses there. Wonderful. All right. But again, OR is very loose, right? OR includes solutions to either inequality. All right, continuing on. All right, so now we're getting into the other objective, right? Solve a compound inequality involving intersections. Unions involve the word OR. Intersections involve the word AND, connecting the two inequalities. Right. So once again, I'll write this out and work on it on a separate piece of paper. All right. So with the word AND, connecting inequalities. All right. The only numbers that belong to the solution set are numbers that satisfy both inequalities at the same time. So they can't just satisfy the first one and not the second one, or they can't satisfy the second one and not the first one, right? They have to satisfy both in order to belong to the solution set. And another way of putting that is to say that the number belongs to the intersection of the solution sets of each of these inequalities. All right, but I'm not going to worry about saying all that. All right? So any number that satisfies both inequalities, and it's got to be both, belongs to the solution set. Inequalities belongs to the solution set. All right, so it's a lot more restrictive than the word OR. All right. So once again, I still solve both of them. All right. This first one, I would multiply both sides by positive 4 and get x on the left is greater than or equal to, negative 1 times positive 4 is negative 4 on the right. Okay. Again, I multiply by a positive number, so this symbol didn't change. All right. And here I would, add 4. That would give me negative 4x is less than or equal to 1. And then I would divide by negative 4, which would flip the symbol. Get x is greater than or equal to negative 1/4. And again, don't forget this is connected by the word AND. So here's what I like to do for AND graphs. Right, OR graphs, I put them on the same level. For AND graphs, I'm going to do one above and one below, and I'll show you why. All right. So the numbers that show up here, negative 4 and negative 1/4 would be to the right of negative 4. Right? There's negative 4, there's negative 1/4. Above the line, I'll put the graph of the first inequality. X is greater than or equal to negative 4. So that's all these numbers to the right of negative 4 and including negative 4. Right? So a bracket there or a closed point. So there's the first inequality. All right, then in a different color, if you don't have different colors, don't worry about it. But then below the graph, below the line, I'll put the graph of the second inequality. Right? X is greater than or equal to negative 1/4. That's these numbers, all the numbers, to the right of negative 1/4, including negative 1/4. And then for these and inequalities, we look for the intersection of the graphs, or the overlap. Right? Where do these overlap? Right? Look for overlap in the graphs, because those numbers where there's overlap, those are numbers that are on both graphs. They satisfy both inequalities at the same time. All right, so the overlap here, these numbers from -4 to negative 1/4, these are on the first graph but not on the second one, so they don't overlap. But these numbers from negative 1/4, right, all the way out to infinity, it looks like, forever, there's your overlap. There are the numbers that are on both graphs. They satisfy both inequalities at the same time. All right, so if I'm going to make now, I'll make I guess I could call this a rough graph where I looked for the overlap, and then I'll make a final graph where I actually write the solution set. So here's the number line, and looks like the numbers that satisfy both are just these numbers from negative 1/4 and to the right. So the numbers to the right of negative 1/4, right, all these numbers are on both graphs. Then how about negative 1/4 itself? Well, yeah, it's on the top graph, it's on the bottom graph, so it is included in the overlap, in the intersection. So there's the final graph, and then there's a picture of the solution set to this compound inequality. Every number from negative 1/4 upward or greater satisfies both of these at the same time, and you can test that out. Plug in some values like 0, 1, 2, 3, and you'll see that both of these would be true. All right, and then the interval for this, which is what they're asking us for, always going left to right, starts at negative 1/4, comma, and then there's no right end of this, so we go to infinity. Negative 1/4 is included. All right, negative 1/4 is included. So bracket on that. That is a solution to both inequalities at the same time. And infinity is not a number, so always, always, always parentheses on the infinities. Right? So there's what they're asking me to enter, right? The interval notation describing the solution set of this compound inequality, and that's what I'll enter. All right. So once again, I think I have, okay, I'm back. I'm on the basic, right? So infinity symbol showing up there. So I got bracket, negative 1/4, comma, and then infinity, parentheses, right? Parentheses. All right. And submit. And it's like, great, hooray, you did it. All right, so again, for these and inequalities, I like to do one on top of the line, one on bottom, one below the line, and then look for their overlap. All right, you're looking for numbers that satisfy both. A lot more strict than or. Right, the or inequalities are easy by comparison, I feel. All right, moving on. So once again, we're solving compound inequalities involving intersections. That means the word and is involved. So again, I'm going to write this out, do it on a separate sheet of paper for you, and then we'll come back and type the answer in. Alright, so this left inequality, first I would multiply by 4 to get negative 3x is less than 12. Then I would divide by negative 3. Now dividing by negative 3 will switch the symbol, makes that is greater than, and 12 divided by negative 3 would be negative 4. Right? So there are the solutions of the first inequality, but that doesn't mean they're solutions of the compound inequality, right? Remember I said from the earlier example, for and inequalities, numbers that are in the final solution set have to satisfy both at the same time. Alright, then here I would subtract 6 first, giving me 4x is less than negative 9. and then divide by positive 4. So x is now it's positive 4, so the symbol doesn't change. And then we have negative 9 divided by 4, negative 9/4. And again, these are connected by the word and. Alright, so here's what I like to do, and I mentioned this in the earlier example on this objective. I'll put the numbers that are mentioned here. So negative 4, negative 9/4, that'd be negative 2 1/4, so that'd be to the right of negative 4. So here's negative 9/4. And then I'll graph each one, but I'll graph one above and one below the line, and then we'll look for the overlap, right? When you see the and connector, you're looking for overlap. You're looking for the numbers that are on both graphs at the same time, satisfy both inequalities. Alright, so x is greater than negative 4. That's all these numbers, right, to the right of negative 4, but not including negative 4. So negative 4 is not on that graph, but all the numbers to the right of negative 4 are. And then below the number line, we have all the numbers less than 9/4. So that's the numbers left of 9/4, but not 9/4 itself. Right, so again, an open point there. Now I'm looking for overlap. What numbers are on both? Well, these numbers are not, they're on the second graph, but not the first one. These numbers here to the right of negative 9/4, these aren't either. They're on the first graph, but not the second graph. Here is the overlap. All the numbers between negative 4 and negative 9/4, they're on both graphs. So I'm going to make like a final graph here. Again, here's negative 4, negative 9/4. And we're seeing that, again, all the numbers in between them are on both graphs, right? All the numbers in between negative 4 and negative 9/4 would satisfy both inequalities at the same time, satisfy the compound inequality, however you want to say that. Now, how about negative 4 itself? Well, let's see. It's on the second graph, sure, but it's not on the first one, right? I had that open point. So negative 4 is not on both. It's not in the overlap. So it's not a solution of the compound inequality. So yet again, I have an open point. Same thing with negative 9/4. Negative 9/4, is on the first graph, but not on the second one because of that hole. So it's not on both, meaning it's not in the intersection, not a solution of the compound inequality. So there's the final graph. There's all a description of all the solutions to this compound inequality, all the numbers that would satisfy both, and then I'm going to write this piece here in interval notation. Going left to right, there's only one piece. You just got negative 4 up until negative 9/4, and neither one of those numbers is a solution. So we have parentheses on both of those, right? So there's what they're wanting me to enter right now. Right? So I go back and enter that interval. So I got parentheses, negative 4, comma, negative 9/4, parentheses again. Right? There's the interval notation for all the solutions. Wonderful. And again, they're showing you graph them both, and then look for the overlap, and that'll make your final graph. Right? They did that here. All right, moving along. All right, so I'm still in that objective involving intersections, right? The word and. So once again, I'll write this out, and we'll graph both of them and look for the overlap, right? Look for the intersection. Okay, so we have x is greater than or equal to 0, and x is greater than or equal to negative 5. Now both of these are already solved for, right? The variable's already alone. So I can go to the graph now. Now if you recall from, again, earlier examples with the word and I've done, I like to graph one on top, one on bottom, and then we're going to look for the overlap or the intersection of these graphs. So the numbers mentioned here are 0 and negative 5, which would be to the left of 0, right? Just make sure you're putting numbers in their proper places with respect to each other. And the first graph I'll put up above the number line. So So we have x is greater than or equal to 0. So that's all the numbers to the right of 0 or 0 itself, right? So I'll put a closed point there or a bracket. There's all the numbers that satisfy the first inequality. Then below the number line, I'll put the second graph. X is greater than or equal to -5. Greater than -5, so all the numbers to the right of -5, or equal to -5. -5 is included in that second graph, so a bracket or parenthesis, or a bracket or a closed point there. But now I'm looking, because again the word and is involved. I'm looking for the overlap, right? If it was the word or, all these numbers would just belong to the graph, right? All these numbers would be satisfying one of these. But the word and, I'm looking for the numbers that satisfy both. And that's the numbers from 0 onward, right? All the numbers from 0 and up are in the overlap or the intersection. Right, these numbers to the left of 0 here, that's, they're on the second graph but not on the first one. Yeah, so all the numbers, it looks like, from 0 upward, 0 and to the right. So I'm going to make a final graph where it looks like, again, all the numbers just from 0 and up. Right. All the numbers to the right of 0 are clearly on both graphs. 0 itself is also on both graphs, right? It's a closed point up here. So that's why I got a closed point above 0 down here. Right? And that's it, right? Don't need to mention -5 because these numbers to the left of 0 don't satisfy both. I'm only pointing out the overlap, the intersection, when this word and is involved. And now that I have a picture of my solutions, we can write an interval. This picture, this piece of solutions goes from 0 to infinity as you go from left to right. 0 is a solution of the compound inequality. And infinity always has parentheses. Infinity is not a number, right? And this is what they're asking me to put in, right? The interval notation for the solution set. That's what I'll do down here, right? Go to the open box. We got bracket, 0, comma, and then infinity, which is showing up down here. Parentheses, right? And that's what they want from me. Wonderful. Again, they show you how they graph both and then look for the overlap, right? The overlapping region is in the third graph that they draw. All right. And one more time, intersections, these and inequalities. So once again, I'll write this out, we'll draw it up. Alright, so here once again I have the word and connecting two inequalities. So first I'm going to solve both, and then we're going to look for the numbers that actually satisfy both at the same time. First one's simple enough. I would just subtract 5. So if x is greater than, -3 minus 5 would be -8. This second inequality, first step I would add 5. We'd have -2x is less than or equal to 6. And then I would divide both sides by -2, which would flip the symbol, right? Dividing by a negative number. So this becomes is greater than or equal to. And then, 6 divided by -2 would be -3. So I have x is greater than -8, and x is greater than or equal to -3. Alright, so I'm going to make a rough graph first. Right, remember with these and inequalities, I like to do this where I put the first graph above, so x is greater than -8. Well, the numbers that are showing up in these are -8 and -3, which would be to the right of -8. Right. Make sure you're putting numbers in the proper places. X is greater than -8. That's all the numbers to the right of -8, but not including -8. So I'm putting an open point or a parenthesis above that -8. So there's the first graph, all the numbers that satisfy the first inequality. Second graph, all the numbers that satisfy the second inequality are the numbers greater than -3 or equal to -3. Numbers greater than -3 are to the right of -3 and equal to -3 itself. So I put a closed point or a bracket underneath -3. So now I have the numbers that satisfy the first inequality, the numbers that satisfy the second one pictured. We're looking for, and. We're looking for intersection. So I am looking for the numbers that satisfy both, looking for the overlap, and that would be these numbers from -3 and up. Right? You can see they're all these numbers from -3 and above are on both graphs. Right? So I'll make a final graph where the only number that really matters here is -3. All the numbers left of -3 don't belong to the second graph, so they wouldn't even be in the solution set. So all the numbers to the right of -3 are on both graphs, and so is -3, right? See, -3 is on the graph up there, it's on the graph down here. So it is also satisfying both inequalities. It would belong to the solution set. Put a closed point or a bracket on that. So here's a picture of the solutions of this compound inequality. And interval notation, right, going left to right for this picture. We're going from -3 to positive infinity. Bracket on the -3 since it is a solution, and parentheses on the infinity, right? And that's what we're asked to enter, the interval notation for that. So that's what I'll do. Alright, so back here, got bracket, -3, comma, and then we're going to infinity, parentheses, submit. It says great, wonderful. Now I have completed that objective, right, one of the two. So the only ones I have left now are some questions about, unions, the or inequalities. So yeah, solve a compound inequality involving unions. Two inequalities connected by the word or. Now remember, the word or is very less restrictive, right? Any number that satisfies the first one is a solution of the compound inequality. Any number that satisfies the second one is also a solution of the compound inequality, right? Any number that satisfies either one belongs to the final solution set. So this is much, much less restrictive than the word and. Alright, so just like before, I'm going to write this out in a picture and do it for you. Right? Alright, so solve each one individually. This first one I would add 4 first, giving me -4x is less than or equal to +4. Then I would divide both sides by -4. And that would flip the symbol, right? Dividing by a negative flips this, becomes is greater than or equal to, and then 4 divided by -4 is -1. And we have the word or, and then the other one, I would add 4 to both sides, giving me 4x is less than or equal to 9, and then divide by +4, and that's a +4, so the symbol wouldn't flip. And I get x is less than or equal to 9/4. So here's a description of all the solutions, right? All these numbers satisfy the first one, so they belong. All these numbers satisfy the second one, so they belong, right? The word or is very inclusive. So when I make a graph, I don't do the thing with the and inequalities. I do one above, one below, and look for overlap. I'm not doing that here. I'm just going to do them on the same level. So the numbers mentioned are -1 and +9/4, which would be to the right of -1. Then all the numbers greater than or equal to -1. So all these numbers are solutions of the compound inequality because they satisfy at least one of them. Right? They satisfy the first one. Also, the numbers less than or equal to +9/4. That's these numbers. And to the left of 9/4. And look at that. When you put them together, when you put these together, that encompasses everything. So like an earlier example I did in this video, we're seeing that every number, all real numbers, are solutions. Let's put all real numbers, like the little octothorpe for number. Yeah, no matter what number you pick, it's going to satisfy this inequality or that one. And it's going to satisfy at least one of them. So every single number, every real number, is a solution to this compound inequality. And then the interval notation for this would be from -infinity to +infinity, right? And there's no gaps, no breaks, no holes, and always parentheses on infinities. Right? So there's your interval notation for all real numbers. And that is what I will enter. Right, so back here, now parentheses. Now there's no infinity symbol here. So that means I have to change the keyboard to basic, where I'm seeing infinity. Right, oops, the minus sign. I forgot the minus sign. Minus infinity. Then comma, and then to positive infinity, and then close the parentheses and submit. The parentheses are already there. Wonderful. Right. And again, they go through the explanation. All right. So it looks like I got one more. Right, one more question involving unions. So again, I'm going to write it out and do it on a separate sheet of paper. Alright, so as with all the other examples, I'm going to solve each one separately, and then, hey, this is the word or, so just all the numbers that satisfy the first one belong to the solution set, all the numbers that satisfy the second one belong to the solution set, right? I'm not looking for overlap. So first inequality here, I would subtract 4, and give me x over 4, x divided by 4 is less than -1, right? 3 minus 4 is -1. And then I would multiply by positive 4, so the symbol wouldn't flip, right? It would still be is less than, and then, -1 times 4 is -4. So I have all the values less than -4 would satisfy this first inequality. Or, and then here I'm subtracting 2, we get -x is less than 0. And then I would divide by -1, which would flip the symbol, because you're dividing by a negative, so x is greater. And then 0 divided by -1 would just be 0. Right. So here's a description of all the solutions, and let's make a graph. And like I said with the previous example on unions, when there's an or inequality, I'm just going to put both graphs on the same level, both graphs above the number line. So the numbers mentioned here are -4 and 0. And just make sure you put in 0 to the right of -4. And all the numbers less than -4 are these numbers, but not including -4, right? -4 is equal to -4, not less than -4, so I put a hole there, or an open point, empty point, or a parentheses. So these are solutions because they satisfy the first inequality, right? Or, and these other numbers are also solutions, all the numbers greater than 0, right? These numbers here, but not 0 itself, right? 0 is not greater than 0. So I put a hole there, or an empty point, or parentheses, whatever you want. And that's it. There's a picture of all the solutions to this compound inequality, right? Each one of these numbers satisfies at least one of these inequalities. All right, now for interval notation, remember there's a gap here, meaning we're going to be using that union symbol again. So the first piece, the first interval goes from negative infinity up, and you're always going left to right when you're writing intervals, negative infinity up to -4, parentheses on both, right? Because negative infinity is not a number. -4 is not a solution to either inequality, right? So parentheses on that. Then the symbol representing the word or, the symbol for this gap, the union symbol, right? Big U. And then the next piece of the graph, the next picture of the solutions, we're going from left to right from 0 to positive infinity, right? And parentheses on 0, right? 0 is not a solution to either inequality, not a solution to this compound inequality, and always parentheses on infinities, and there you go. This is the interval notation describing the solution set to this compound inequality, and this is what I will enter. All right, so here, all right, that first interval was parentheses negative infinity. Now I'm seeing the infinity symbol here, comma, to -4, parentheses again. Then the union symbol, which is I'm seeing here, to represent that gap, right? The space between, and it also represents the word or, kind of in set notation. Then parentheses, we went from 0, comma, to infinity, right, with a parentheses on 0. And then close the parentheses. There's the interval notation describing the solution set. Great. And they do the answer explanation here. And that should be it. Looks like I've completed both objectives, completed the assignment, and you should see assignment is complete at the end like this, but without the word preview. Right? Great. So, as I said at the beginning of the video,
The questions you see when you work on the assignment aren't going to be exactly the same as my questions, but you do have the same objectives and the same kinds of questions, and the way you would go about solving them are the same. So I'm hoping that watching me go through these several problems here help you out when you're working on the assignment on your own. And thank you very much for watching.